going to take a fresh look at quadratics for your SOL review. This problem, a lot of you had questions on the review, one shortly like this. We don't necessarily use manipulatives, but basically the squares are the x squareds, the rectangles are x, and the little squares equal 1. Okay, it's just like the area model that you learned way back in elementary school. So if I multiply x plus 3 times x plus 4 using either distributive property or the box, I'm going to get x squared plus 3x plus 4x plus 12, or x squared plus 7x plus 12. So I've got 1x squared, so that's all x squared, so that's 12x squared, and I need 7 x's. So 1, 2, 3, 4, 5, 6, 7, 8, so that one doesn't work. This one has the same number of x's as 1s, that's not going to work. But this is an x squared, and then I've got 1, 2, 3, 4, 5, 6, 7 x's, and this is 3 by 4, or 12 ones. So it's this right there. Okay. We talked about this in class. I've seen one of these kind of problems on every released test that was given. And remember, we want to completely factor. So the first thing I'm going to do is I'm going to factor out the greatest common factor of 2. So if I factor out 2, I'm left with 4x squared minus 9. A lot of people jump right at this 4x minus 9 and the 2. Well, the 2 is definitely factored all the way, but the 4x squared minus 9 is a difference of squares, and it can be factored as well. So the square root of 4x squared is 2x, and the square root of 9 is 3. So remember, 2x minus 3 and 2x plus 3. So those 3 right here are my factors. We don't include this because while it's a factor, if we just pull out the common factor, it's not completely factored, so it needs to be factored all the way. In this equation, we want to use 2 of the factors to create a possible equation for the graph relation. So here, my x is equal to 2. Here, x equals negative 3. So remember that zero power property that says that we put factors together and set them equal to 0 and solve. So if x minus 3 equals, or x equals negative 3, okay, if I want it zeroed out, I'd have to add 3 to both sides, and I would get x plus 3 equals 0. With the x equal to 2, if I was to bring the 2 to the other side, x minus 2 equals 0. Remember, those x-intercepts are solutions, so we get them from those zeros. If you weren't sure which ones to use, you could have just taken each of those factors and set them equal to 0 and solve. So here I would subtract 2. X equals negative 2 is not one of my solutions. X plus 3 equals 0. I subtract 3. X equals negative 3 is one of my solutions, so I know that's a factor. Okay, and then I've got the x minus 2 as a factor. So if you weren't quite sure how to do that, you could have worked backwards to find those factors. Okay. Now we have the graph of y equals negative x squared plus x plus 12. We want to plot the solutions to negative x squared plus x plus 12. So remember, solutions are x-intercepts. So there are my solutions right there. Okay, so these are related. We're just putting 0 in for y, and those are your solutions. Remember on the SOL that you can't use the arrow or the pointer. You have to use the dot function to actually plot those. Otherwise, it'll look like you didn't answer your test. Okay. What are the zeros of this function? Again, we can write it as 0 equals 6x squared minus x minus 2. And I can find factors of negative 12 that add to negative 1. And that's going to be negative 4 and positive 3. So we can split the middle term. So 6x squared minus 4 x plus 3x minus 2 and factor. The greatest common factor here is 2x, and I'm going to get 3x minus 2, and the greatest common factor here is 1, so 3x minus 2. So my factors are 2x plus 1 and 3x minus 2. Okay, and if I set those equal to 0, okay, I'm going to subtract 1 and get 2x equals negative 1 and divide by 2, x equals negative 1/2. Down here, if I add 2, 3x equals 2, divide by 3, x equals 2/3. Now it's in standard form, so we can use the graphing calculator. Okay. So in your graphing calculator, we're going to go to the stat menu, or I'm sorry, the equation menu. And this is polynomial. So I've got F2. The degree is 2. That's the highest power. Okay. And just plug in my A, B, and C. My A is in front of the x squared. It's 6. Then negative 1 is in front of the x, and then negative 2 for the c. And I can just solve it, and you can see I get 2/3 and negative 1/2. So just another way that we can solve that. Okay, let's do one more example. This one, what are the zeros of the function 25x squared minus 1? Since we have the graphing calculator up, I'll do it with the graphing calculator. I can clear this and start over. Okay, so here, remember that your A is 25 because it's in front of the x squared. Your B is 0 and your C is negative 1. Okay, so that's what I'm going to put in, 25, 0, negative 1. And when I solve that, I'm going to get 1/5 and negative 1/5. Okay. So if the x is going to equal 1/5 and x is going to equal negative 1/5. If I were to solve this by factoring, 0 equals 25x squared minus 1, perfect squares, difference of squares, so 5x minus 1 and 5x plus 1. If I set those equal to 0, in the first one I have to add 1, so I get 5x equals 1, and if I divide by 5, x equals positive 1/5. Here, I'm going to subtract, so I get 5x equals negative 1 and x equals negative 1/5. Okay. So just a quick little quadratics review, a couple calculator hints. You guys are going to do great on this test. I know it. I believe in you. Have a math-tastic day.